Now, I would like to hear about a description of ideas for larger systems, and I bring Mr. Bengt Gudmundsson and Edward Jobson from Volvo and Siemens having a collaboration together.
Thank you.
So, yeah, if I start, yes. My name is Edward Jobson. I'm Environmental Director at Volvo Bus Corporation, as well as Associated Professor at Chalmers University in Environmental Technology. So, Volvo Buses has a production plant in Bangalore, India, where we have just introduced the new hybrid technology. So we are selling to Navi, Mumbai, and they are just being brought into service. So we are happy to be able to follow the global trend with equal pace in India. Yeah, I think that's it. Yeah. Bengt.
Okay, my name is Bengt Gudmundsson. I'm the CTO of Power and Gas Distributed Generation within Siemens. And Siemens has a long history electrifying the whole world. We have been around since 1847. The first presence in India was in 1867. There was some telegraph line that Siemens supported with there. Right now we have 13 companies in India. These 13 companies have 23 manufacturing facilities and 11 R&D centers. And in total, we employ 16,000 people in India. Siemens sort of stands today for electrification, automation, and digitalization. And one example of that is a project we have with, let me see, I have to read here. It's the Maharashtra State Electricity Company. The aim of this project is to make the electrical grid more reliable and also to have reduced the losses in the electrical grid. Siemens is managing this project, and it's about to optimize the grid between 8 cities in India. I think that was sort of the introduction.
Because I just remembered what I forgot. What I wanted to mention as well is our production plant in Pithampur, which is actually exporting the Euro 6 engine, the most modern engine technology in the world, to Europe. So we're actually producing those engines in India. And we are quite proud of that. Now to the subject of today. What we want to present is something that is new. We have been having a cooperation between Volvo and Siemens for roughly 6 months. We were sitting on the chamber ourselves and doing some back-of-the-envelope calculations, and we found that a surprising effect of utilizing electric energy on vehicles such as electrical buses when you take it out of the grid context. So, provided that we can actually use dedicated energy, we get an excellent balance. We didn't believe this ourselves, so we turned to Siemens, who are working on those solutions in reality and making gas turbines. So we wanted to compare our data and see if they came to the same solution. So we gave them some hints, and they did come to the same conclusion. So what we present is something that will be solving air quality issues, waste issues. You already heard about the biogas that you can make from wastes. So this is another piece of this puzzle. We go into smart living, district cooling. We will be providing public transport, so you will solve a lot of congestion issues by clean technologies. So there is, and of course, the connection to the grid. By having an energy storage, we are not immediately needing the power exactly as we stop at the bus stop. We can ask for the power that is available from the grid. So when we put all this together, we find some surprising effects that we want to present. Bengt.
Yeah, okay. So what we sort of looked at then is waste management, and we looked on Delhi, state of Delhi as an example, and the total waste in state of Delhi is around 11,500 tons per day. which is from Swedish measures. I mean, we come here and it's sort of stunning amount of waste, and you could actually transform this waste into biogas. And we did some preliminary studies, Edvard and myself, and talking to Swedish biogas companies, we came to the conclusion that we can produce roughly 500 tons of biogas of this waste. And 500 tons of biogas can be used to fire a combined cycle power plant in the size of 130 megawatt electricity, which is quite a large power plant for Swedish measures. For Indian measures, it's smaller, but at least it's a sizable power plant. At the same time, then, we can also generate district cooling. So we will get about 120 megawatt of district cooling as well. So the total efficiency of this system, generating the biogas from the waste, firing this gas into a gas turbine, generating 130 megawatt electricity, 120 megawatt of cooling, is 87%. So it's a very good total efficiency of this system. And the district cooling can be, as we looked on some numbers, we are not experts in district cooling, but looking on the references, we find that you could actually cool 350,000 apartments of 100 square meters, which is a large number of apartments for the cooling.
Literature data. Yeah.
Yes, that's literature data, and has to be scrutinized more in detail, we would say.
Yeah. So now you wonder, why do we write 69% when the efficiency is 87, you said, right?
Yeah.
Yeah, and the reason is that we have losses in the bus. So when you provide it to the grid, it's 87%. But when you consume it in the bus to actual work, you will have further losses. But compared to the losses that we have in the traditional route, if we would make just biogas and fire it in normal gas buses, which we do produce in India as well, this amount of gas that we can produce on a daily basis would be enough for 5,000 gas buses. That would be a lot of buses in Delhi. It will not be all the buses, but it will be a substantial part. However, if we use the same amount of energy, we go via electricity, we can use it for 20,000 buses with the same passenger capacity. So this is how we create this surprising effect that was new even for us. So yes. Yeah, so that was about the system itself.
Yes, so that's the general storyline, and now we come into some details about emissions.
Yeah, and we have to bore you a bit about this as well.
Yes, and I mean, just for the power plant, by converting to biogas and using the sort of European norms of calculating how you would reduce your CO2 footprint with biogas, you would reduce it by 65%, the footprint. So that's a substantial reduction of the overall CO2 footprint. The 35% remaining is the energy required to produce the biogas. So there is some losses in this process as well. And on top of that, which I have not taken into account in this calculation, you get for free cooling of 350,000 apartments. So this number will be even higher when you do a more detailed study of this. But then, of course, you need to know what is the actual cooling, the requirement, and so on. And for that, you would need to have more detailed discussions.
Okay, with respect for the other peoples, we will stop it here. But you can see that the emission data is excellent. So, and this is compared to European Euro 6 engines. So if you compare to the status of the buses in Delhi today, which are gas buses, it will be roughly fourfold more difference. So you will have an enormous impact on the air quality by going this route.
Yeah. And of course, Edvard and I are very interested to continue discussions around this concept. I find it very exciting myself, and so I would appreciate if you would like to discuss further. We are, of course, at your service.
Stay the rest of the day.
Yes. Thank you.